Okay, in this video, I'm going to review improper integrals, which is something you may have seen in Calc 1 or in Calc 2, because when we define the Laplace transform momentarily, it is going to involve an improper integral. So an improper integral may converge or it may diverge, and there are various types of improper integrals. The improper integral that we're going to take a look at is when we have an upper limit that is heading towards infinity. And so the picture maybe of what's going on here is you've got a function and what you're trying to calculate with this improper integral might be how much area is over here. And so sometimes that area is actually a finite number, in which case we say the integral converges. And in some cases, that area is actually infinite. And in those cases, we would say that the improper integral diverges. And so since we can't technically plug infinity into any function, really what this improper integral is a definite integral, and we're going to take the limit as the upper limit of this integral goes towards infinity. So if you've got these fresh in your mind, that's great. If it's been a little while since you've seen improper integrals, just going to walk through an example on the next slide. Okay, so we would like to determine whether this integral from 0 to infinity of e to the minus 2t converges or diverges. And so if we think about the picture here, e to the minus 2t, its graph looks like this. And if we're integrating from 0 to infinity, then what we're doing is calculating the area that's underneath this curve. And what we don't know is whether or not that area is infinite or whether that area is finite. And so that's what we mean by converge or diverge. So let's work out the details of this integral. So first of all, we're going to start by being careful, and we're going to convert this into the limit as n goes to infinity of the integral as the upper limit is heading off towards infinity. And then we can integrate this. We still have this limit. And when we integrate that, we're going to get the minus 1/2 e to the minus 2t. If I were to use integration by substitution here, using w is equal to 2t. And we're going to evaluate this integral from 0 up to n, which is heading towards infinity. So this means we're going to take the limit as n goes to infinity of minus 1/2 e to the minus 2, and I'm going to plug in n in place of t. And then we're going to subtract from that what we get when we evaluate at the lower limit, which in this case is 0. And so if we look at this first piece, if we look at the limit here, as n goes to infinity, what we're getting is basically a really large negative power in e. And so as we take e and raise it to a large negative number, this is going to head towards 0. So that limit exists and it goes to 0. So in the end, when we evaluate this, we get that limit head to 0, and then for the second piece, we would get a minus 1/2. So we actually get plus 1/2. And since we get a finite number, since that limit exists, then we would say that this integral converges. And thus, this area that we had over here in red is actually finite area. And just to compare this to say like what a situation where this might not converge, if we instead were to think about the integral, let's say from 1 to infinity of 1 over t dt. So 1 over t looks like this. And we're going to evaluate this integral starting at 1. So we have a finite value over here, but it's heading off to infinity over here, but it's getting smaller. And so again, the question is this area finite or is this area infinite? So in this case, we would take the limit as n goes to infinity of 1 to infinity, or excuse me, we don't have infinity, we have 1 to n, 1 over t dt, and the integral of 1 over t is the natural log of the absolute value of t, and since t is only taking on positive numbers here, we actually don't need the absolute value. And we're integrating from 1 up to n as n goes to infinity. And so this would mean we've got the limit as n goes to infinity of the natural log of n, when I plug n in for t, minus the natural log of 1, plugging in the lower limit. And so as n goes to infinity, now this limit does not exist. The natural log actually approaches infinity as n goes to infinity. So therefore, this entire integral does not exist, and we would say that this improper integral diverges.